So very quick session on containers. We've got about 30 minutes to go over some of the changes and some of the happenings in the container landscape. Quick question, who is intimately familiar with what's going on in the container world at the moment? All right, what do we reckon? That's like 10%? Who has kind of used containers and knows what they are but doesn't really know how to use them? Okay. Who has no idea what containers are at all and those things? Yeah, they are, yeah, perfect. There's red ones, there's blue ones. Presentation done. Anyone have no idea what containers are? All right, that's pretty good. So a very quick intro. My name's Marc van Hoof. I am with Kumulus Technologies. Kumulus is a cloud integration specialist helping people mostly deploy and operate OpenStack environments for themselves and look at the transition into what happens from a DevOps perspective when you start using a cloud-based environment rather than kind of having your head deep in operational tasks and doing it all yourself. So we're kind of tackling the approach on both the architecture side, the operational side, but also on the developer side in getting them used to this kind of new lay of the land. A very quick overview of what we're going to chat about. We're going to chat about containers in general, where they've come from, why we're here. Believe it or not, a technology that significantly predates virtual machines, which everyone is very familiar with, so we can only assume that VMware had some pretty wicked marketing team on the case. But we're going to talk about containers, where they came from, what they do, why now they're incredibly relevant, changes in development methodologies, changes in how we're deploying code and how we're writing code, and how that lends itself to significant advantages. Well, not only significant advantages of containers, but also the mitigation and minimization of risk of containers that's kind of always been there and is top of mind in most decision making when it comes down to like the whole VM versus container conversation. We'll talk about some of the COEs, container operating environments. So we'll have a chat about things like Swarm and Kubernetes and Mesos and fun stuff like that at kind of a relatively high level, given that we have 30 minutes. And what's missing, right? Because we're kind of in a constant world of development. We're constantly moving forward. The requirements are constantly changing, and for some strange reason, we always seem to be playing catch up with people's requirements. So we'll talk about what's missing and what we think is going to come next. Right. Okay. So containers have existed for a very, very long time, predating VMs, predating all of that, when they were basically initiated as like a chroot environment within a Unix environment. If you think about the concept of just time sharing, right, and time sharing compute resources, this has been around since mainframe days, 50s, 60s, etc., 60s, 70s. But we kind of had security issues and usability issues with just a ch-rooted environment, right? We had this capability of what happens if someone breaks out of the environment. We use it to isolate users rather than to isolate processes in most cases. Enter sort of the mid-90s to late 90s, I guess, and the rapid progression of virtual machines, right? First in a desktop environment with no hardware acceleration, with no assistance. And then once we added hardware acceleration, hardware assistance within CPUs for this virtualization layer, we got the stability, the robustness, and the performance that we expected out of virtualization, right? But they are still, by definition, inefficient. Right? They are still, by definition, slower than we would like. We use them as a kind of super container to try and really isolate resources and protect ourselves against the lowest common denominator of security and of development and all of those things. But realistically, we need something better. We just need it without the risks. And funnily enough, the answer is a combination. Now, what happened is we started with this chroot environment, and then we moved, and container technology evolved, and we had LexC and LexD containers, which were operating system containers. Right? So this is And just while we're at it, everyone familiar with the difference between a container and a virtual machine? Or anyone not familiar with that? No? All good. So we had these LexC and LexD containers that evolved, and they were operating system containers and full system containers that came around, where we replicated an entire operating system environment, file systems, etc. We actually replicated everything except the kernel and the runtime and the things that were at risk. And after a while of that, Docker came around and kind of went with the approach of, well, why don't we isolate applications? Right? Rather than doing this full system or even partial system container, why don't we just isolate applications, run them within containers, and then we have this really fast, agile environment which we can build upon. Anyone familiar with Google's one? LMCTFY? Let me containerize that for you. So, I love when we're running out of acronyms. Right. So we kind of evolved from the full system containers, and we moved into these application containers with Docker coming around, and we had these really light images, and it came along with all these recent developments like a container library and searchable containers and being able to just download a container for the application that you want to run, and shared containers, service chaining, etc., etc. So why not just use VMs? What do you think? What's the big problems? Where are they right and where are they wrong? Because like everything in technology, there's a right and wrong time to use things. So what are your thoughts on VMs? What are the first things you think about? I can't do all the talking. Sorry?
They're heavyweight.
Heavyweight. They are. Right? CPU cycles are finite, as much as we like to believe that they're not. Right? CPU cycles are finite, and if you're replicating running a guest operating system n number of times on a host, you're wasting CPU cycles doing that. What else? Stateful. Absolutely. Right? You're bound within that virtual machine construct, no matter what. Now, that can be a good thing and a bad thing as well, by the way. Right? There's been numerous cases where a third party would offer container hosting, and one client would take down the entire system with some bad code or some bugs or some vulnerabilities or any number of kind of hacks that can go on there. Even a denial of service to one container will take down the other. So we like the isolation sometimes as well, right, from a protection standpoint, and that's where we're going to talk about a hybrid approach. And finally, you know, the other thing about virtual machines, they're heavy to spin up. Right? They're not just heavy to run, they're heavy to spin up. We're talking about like multi-second, right, to minute-long spin-up times depending on the size of the image that we're transferring and where we're transferring it from and what we have to do. Right? So virtual machines are very heavy. Compared with containers, where we're just going to run a series of applications with their own individual libraries, very lightweight, on top of the container engine that sits on our physical hardware. Right? We're talking millisecond spin-up times, but we don't get the isolation that we had before. We don't get the full virtualization that we had with the virtual machine environments. Right? And it's important to understand that that's a benefit. If everything's tested and everything, you know, if we live in or exist in this utopia of technology where everything's tested, there's no bugs, nothing's going to go wrong, then containers are great. Right? But unfortunately, that doesn't always happen. Okay, so as a base definition, just so that we're all on the same page, a container containerizes a process and segments and isolates a process. A virtual machine isolates an entire operating system, right, with the guest operating system. It's important to realize that with a container, there are still several shared functions, right? Shared memory, shared kernel, shared operating environment, etc. Okay, so one process takes out the kernel in a VM, the VM dies. The process takes out the kernel in a container, the entire host dies. Now, the real driver behind a lot of this is the shift towards very agile DevOps. And if we think back 15 years or thereabouts, when we were embarking on development projects and we were writing things in C and we were writing heavy projects that took 12 to 18 months of development cycles, and we compare that to where we're at now, where we're writing in Python and Ruby and you name it, right? Node. And we look at the frameworks that we've got that accelerate things even more. We look at things like Django and Rails, and you look at the speed at which people are developing, and that combined with the shift in hosting infrastructure and the trend towards infrastructure as a service and service as a service, it's really a fast development cycle with a outsourced hosting cycle, with we want to scale it if it works and trash it if it doesn't. And if we want to succeed well. And if we want to fail quickly and cheaply. Okay? And the quickest way to fail cheaply is don't own any infrastructure, don't own any environment, put minimal time and effort into something and just see what happens, right? MVP is a word or an acronym that's been bandied around a lot. And you see this agile development process where, I don't know if there's a ton of Facebook users in the room, but you look at what Facebook does, and every now and then they'll send you an email saying, hey guys, we're going to change some stuff, and then they change it. But most of the time, they just shut up about it, right? And a button moves, and a word changes, and a font changes, and they're doing that numerous times per day, per week, per month, making these minor changes. And everyone else is working on the same methodology. Let's develop an MVP, and then just bounce back and forth based on what our customers are telling us, right? So this DevOps development methodology, right, where we're constantly developing and pushing straight back into an operational model and going back to the development cycle, is really driving a lot of our container use and a lot of the shift towards these kind of rapidly deployable modules, where we might say, well, we need a container that is a web server that has Rails on it. We need a container that is a load balanced front end that we can massively scale horizontally. Okay? Some technologies still suit themselves better to non-containerized environments, right? Databases, etc. You might want to run as a VM or even just on bare metal. So I'm doing kind of 2 or 3 slides at once just in the interest of time. So what we're hoping for is that the ability to have a seamless environment for both test, staging, live, bug fix, etc. Where we can just have a single environment where we can do a full suite of tests and have a consistency in the environment across the end-to-end stages of the application will lead to more people embarking on testing, will lead to more people developing robust code, and will lead to less errors in the production stage if we can emulate the production stage environment more closely in the test stage. Right? And that's what we get with containers, because we can spin up the container on a local laptop, we can spin it up in a closed group for development and test purposes, we can spin it up in the live environment, and it's exactly the same every time we spin up this container environment. Any developers have frustration with differing environments between developing on your local laptop and then deploying to something like Heroku or any of these PaaS providers and finding out the environment is totally different where you're getting your gems from or your includes. You'll feel the pain of that one. So we get this consistency across all stages of our application cycle. Now, there's some things, even when we use containers and we kind of harness the benefits of containers, there's some things that we just can't avoid doing, right? We still need to provision disk. We still need to have network connectivity. We still need to provision reachability to the nodes. We still need to monitor and ensure uptime and all of those things, right? So there's some infrastructure level tasks that we just simply can't avoid. Right? And this is where it becomes very interesting to look at containers on top of OpenStack. Right? for multiple reasons. But OpenStack, if we think about it and really kind of drill down to the bare essentials, is this wonderful automation and orchestration environment that allows us to streamline and proceduralize and automate these tasks across our compute nodes to provision disk, to ensure connectivity, to monitor and to report on availability. So having that as an underlying technology with which we deploy COEs or container operating environments on top of, we have this very nice hybrid where we've got both sides of the equation being taken care of. The challenge is, it'd be nice if they spoke to each other a little bit more, which we'll talk about. So when we look at containers, we look at not only the base level containers that we kind of started with LXC and LXD, we look at the application containers with Docker, and then we look at the application container management systems, of which there is the bulk of competition going on at the moment, right? Even when you see that people, and they are having talks about a unified container format that becomes a standard. But if you look at the real competition at the moment, it's going on in operating environments where, Kubernetes is probably leading the way at the moment. Swarm is probably not. And every now and then you want to say something, you're like, I'll stop. And then you've got things like Mesos and the commercial instantiation of that, which is DCOS with Mesosphere, and at the top end of town, which has the Twitters and the people like that running. There is a lot of contention in this space for who's going to win and what technology is going to win the management side of life. Now, here are the things that you might need to do running a container operating environment. All your lifecycle management, getting rid of nodes that have broken, getting rid of hardware that's broken, getting rid of faulty drives, etc., from your storage array, or faulty volumes from your storage array. Hopefully there's some resiliency within the drives. Upgrading your nodes, taking snapshots and backups and scheduling tasks, etc. Right? All of these things are the kind of unavoidable infrastructure level things that we still need to do. And if you have a look at this list, it kind of looks like a nice little list of things that OpenStack provides. Now there's I love when a slide, 2 ways of managing containers, and there's 3 bullet points. Or 2 ways of thinking about containers, and there's 3 bullet points. Okay, there are 3 ways that containers apply within the OpenStack environment. The first is you just throw a container operating environment on top of either VMs or bare metal, and you just provision containers. Right. Efficient? Yes. Risky? Yes. If things haven't been tested, I mean, particularly, this is the kind of the red flag if you're providing services to multiple different clients or multiple different customers, or even, as a lot of you will know, multiple different departments within the same organization, because they sometimes see themselves as different clients anyway, right? But this is at the kind of the bare level, or bare bones level, the most simple and efficient. If we look at the next one on top of that, which is kind of the hybrid approach, which is probably getting close to current best practice, what if we were to provision a container operating environment per tenant on a series of VMs or on a series of bare metal nodes, and whether we use Nova for the VMs or Ironic for the bare metal, it's just a question of what layer we want to run this at. And then we let the client use and run and worry about their COE over the top of that. Right? Because if the tenant or the client and it's, look, a tenant could be part of a client. We could have 3 or 4, and we could isolate based on applications or divisions or anything like that. But if we do this, we have some kind of limited risk where at least if something does tear down a host, we can say, yeah, but it was something of yours, right? What we don't want is to be providing a service to Ford and Holden, and something goes wrong in the Ford environment and tears down the Holden environment, because there have been numerous cases where things like that, not involving those two companies, have happened intentionally. So that's the second one. And then the third one is a slight different layer of the puzzle, but what happens if we run OpenStack on containers rather than on bare metal? And this does lead to a slight chicken and egg problem, which we'll talk about. Because if you need infrastructure to set up containers and then you need containers to set up infrastructure, it's kind of like watching the movie Inception a few too many times and being confused. So the first question, where are you going to run the container? Right. Are you going to run it on a VM? Are you going to run it on bare metal? Or are you going to run the container directly, which was this whole Higgins project, which is now called Zim. So we have multiple places that we can run these containers, and really it's a business decision. If we end up with this hybrid approach, VMs are enticing because we can have some VMs that are running containers and some VMs that aren't. Right? And we can provide a VM to a particular tenant that's containerized and part of a COE that's running a Swarm cluster or that's running a Kubernetes cluster. And then we can provide a VM to another tenant that is just running a single application, has no COE running on top of it. The problem is that we start having a sizing issue, where if we're sizing a VM that is divided and split up into containers at the same size that we're instantiating a VM that is just used for a single process or a single server, there's obviously contention there about which clients are getting what. Right? And ensuring that there's an adequate amount of resources left for the individual containers. And then how do you launch containers? Are you going to launch them directly? Are you going to use Docker commands and launch the lightweight application containers? Or are you going to use some kind of operating environment, whether it's Mesos or Kubernetes? Then you've got to add management. What are you going to do about storage? In most cases, you're either going to do something to do with NFS or iSCSI, but you need to provide storage back to those COE nodes, somewhere where they can mount the container. And what are you going to do about networking? How are you going to get the networking connectivity back in a predictable, reliable, automated fashion to the container nodes? What are you going to do about load balancing? Remember, everything we're talking about here is to do with these highly scalable or highly horizontally scalable applications. So what are you going to do about load balancing services? Are you going to provide them in software? Are you going to provide them in hardware? What system are you going to give Kubernetes to talk to provision and divide its traffic amongst the available containers? From a scheduling perspective, there's still a fair way to go. We have no ability to deal with affinity groups or anti-affinity groups in containers at the moment. We have an issue where there's a disconnect between the hardware scheduler and the container scheduler. Right? There's no communication at the moment between something like Nova and Kubernetes, which we would want to ensure that we were placing containers in the right spot, and we weren't just adding VMs and dividing hardware that was already allocated. Right? Because if we're just adding VMs into onto a node that already has we're going back to what we were talking about earlier on, which is if we start dividing some VMs and not dividing others, we're going to hit contention, and we want to have some kind of clarity around what we're doing, some kind of control around what we're doing about where we're going to place container VMs and where we're going to place standalones. And that kind of leads us to, well, are we seeing a COE as different to any other application? And should it be treated differently? I'm going to be quick. Right, so the real decision to be made is, if we're going to go down the path of containers, are we going to run a single container operating environment across the entire OpenStack cloud over hardware or VMs, or are we going to run it per tenant in a semi-isolated environment? And as you can see, I think the benefits of virtualization in a VM capacity strongly protect us against some of the things that can potentially go wrong in a container world. Now, finally, there is a fair bit of talk at the moment about OpenStack running in containers. How you would provision that is where the challenge is at the moment. Has anyone heard of Bifrost? Yeah, so Bifrost is being targeted as a candidate to deploy a very lightweight OpenStack environment, use that to then deploy a Kubernetes environment over the top, and then use Kubernetes to run the OpenStack services within containers. It's still probably more complicated than you'd want it to be, but there's a lot of discussion happening there. Similarly, there's a lot of discussion happening in terms of the OpenStack automation layers talking to the container operating environment automation layers, and who's going to bridge that gap. If you want to have a look into the OpenStack running as containers, have a look at the KOLLA project. Keep in mind that the KOLLA project is a single, almost like a one-time deploy project, not an ongoing management and maintenance thing that you would rely upon. So the chicken and egg issue, who's first? To run OpenStack, you need hardware. To run Kubernetes, you need hardware. You're going to need to deploy that at some point. This is still a point of contention. Do they get the slides on? Yeah, all right. All the slides are available, so we've got some links in there for you. And just to summarize, we have a very strong tendency, or not, we have a very strong use case now for containers, right? The DevOps environment, the shift in technology, the shift in reliability, the desire for rapidly scalable or rapidly horizontally scalable applications that are often responsive to immediate circumstances based on load, based on response times, etc. We want to be able to scale very rapidly and very quickly. And with a tested application where we've got no issues, we absolutely rely upon containers to do that. Right? We like the protection of virtual machines, so deploying a COE on top of a VM environment, not necessarily such a bad option, gives us that separation. We need to ensure scalability, scheduling, security. For those types of things to deploy the actual COE, OpenStack is a perfect candidate. And running containers on top of an infrastructure as a service layer will really bridge the gap and give you the best of both worlds. Am I running out of time? Okay, a little bit. Any very quick questions? Nope.
Will you be available during the tea break?
I will.
For some questions? Excellent. If everyone would please join me in thanking Marc for his talk on containers. Thank you so much.